Was the relevel platform working for you? It was not working for me for some reason today. So we had to move to this alternative arrangement. Okay. All right. Okay. All right. Maybe it was some issue on my side because I was not able to join in the class, start the class in relevel platform. So eventually, I had to tell the SSM about this problem, and he set up the Google Meet call. Okay. All right. So how are you all doing today? Doing good? You had a good weekend? I mean, at least start to the weekend. Yeah, hi everyone. Hope you're all doing fine. Okay, so allow me a couple of minutes here. I just need to set up a few things, okay? And in the meantime, I'll also wait for other folks to join in. I'll just be back in 2 minutes, okay? All right, I'm just back. Am I audible? I hope so. Okay, great. So can we get started, or you want to wait a couple of minutes until 8:20 for others to join in? I want to make sure people are also here. Most of the people who wanted to join are here, right? Okay. All right. In the meantime, I'll just get set up with my. So you're not able to view my screen yet, right? I don't think I've shared my screen yet. Yeah, I don't think so. Okay. All right. Okay, I'm just pulling the last. So last, I think that was last Wednesday, right? We had looked at a couple of problems, and we had a spillover from that session, and we'll be first looking at that problem, and then moving on with the today's problems that we're going to be essentially working on, right? Okay, allow me to essentially get that problem statement here. Okay, I'm just trying to pull that problem here. Okay. All right. Can you see this screen right now? Not yet, I suppose. Okay, I need to share. How about now? Can you view my screen? Okay, great. So let me set this screen up properly so you will be able to see, and I will also be able to see the chat window. That way we can make it interactive, right? Okay. So last session, right, we looked at 3 of the problems, and I think we stopped at the last problem, which is the string strength. We discussed a little bit about it in terms of how it needs to be approached, right? So I'm going to go and open the whiteboard one more time, right? So let's go to the problem that we were looking at, right? The string strength, right? Okay. So yeah, I think we all know the problem statement here, right? So we have a given string, and we want to find the string strength, right? So let's actually discuss that first, and then we go on to the coding part. Yeah. Okay. So so we have a string, right? I think we discussed this a little bit, but I'll still go over that one more time, right? So let's so we have a string, and let's say random, right? So let's say I'm going to say this is my string, right? Random. Okay. And so we want to find the string strength. Yeah. So how do we define string strength? So the string strength is defined by the, let's say, ratio of the number of unique characters right, and divided by the total number of characters, right? Right. So in this case, what do we get here? So we have, how many unique characters do we have here? We have about 6 here, right? And what is the total number of characters? It is also 6, right? So we have a string strength that's actually at 100%, right? Okay, let's take another example. So what do I take? So let's take this one, right? I would say Johnny. Right? Oops, give me a moment here. J-O, this is H-N-N-Y, right? So if I take this string, right? So what is the total number of unique characters here? There is 5, yeah, and the total characters is 6. So that's 5 divided by 6. So that gives you a string strength of how much? About 80%. This is going to be about 0.83, right? So about 83%, right? 83%, right? So this is how you would calculate the string strength, right? And as I mentioned before, this concept is actually used in a lot of things. One is obviously to capture the strength of the password, right? And also, I think a lot of the hashing algorithms might use this as well, right? So you would have heard about a lot of hashing algorithms, for example, SHA-256, or for that matter, MD5, right? So all those things you would have looked at, and I'm sure as you move forward, you'll also learn more about them because they have a lot of practical implications or practical application as you move along, and as you start building up projects, and also the projects, and of course a lot of the applications in your software engineering career, right? Okay, super. So let me do this. I'm gonna okay, great. Super. So there we are. Okay, so how do you actually get this, right? So what is a brute force that you can work with here? Can you tell me? What is a brute force here? If you were to solve it with brute force method, how would you go about it? So essentially, if I were to do this brute force, right, I would maintain, let's say, a couple of pointers, right? One for the outer pointer, or the outer loop, and the inner loop, and I would start here, right? And then go through the entire list, right? And check, if any of the combinations, right, will yield me a and then count the number of, let's say, unique characters, right? So I would start with AR, and then I would go with A, right? And then gradually move towards all the other characters, and then find the count. And then likewise, I would then, once this particular stuff is done, I would go from here, right? I would start here and then go from here, right? So this would actually result in a essentially calculating or computing the length of all the substrings, right? So that's how I would do it. And again, remember, there we are actually trying to compute the let's say a substring which has unique characters, right? And we want to find a substring which has the highest number of unique characters here, right? So that's what we're trying to do. Yeah. And with this particular solution, right, with let's say an outer loop and an inner loop, right, this would essentially lead to a kind of an O(n) square solution, right? Because this is of size n, right? And since we are actually trying to find the substrings for each of the characters, right? So worst case, it would be an O(n) square solution. Do you agree with me? Do you agree with me when I say it's an O(n) square solution? Can you hear me, folks? I hope I'm audible. I'm not essentially getting any audio from the other side, or rather the messages as well. So let me know if you're not able to hear me. I can check my audio settings here. You want me to raise the audio levels or something? Can you hear me? I'm not getting any kind of let me try the chat board. Okay. Can you hear me all right? Okay, all right. So I was just asking a question. If we go through the brute force method, it would lead us to a kind of a O(n) square kind of a time complexity, right? So and possibly some kind of space complexity as well, because we need to check whether a certain character has already been encountered or already has been processed before, right? So do you agree with me when I say it's O(n) square, or do you have a different point of view? Okay, great. So let's actually look at how we can essentially. So, but O(n) square, while it's okay, it'll make your program run. For longer, let's say, strings, that cannot be acceptable, right? It may not perform at the best possible level at all times. For smaller strings, it's okay. It may not be a big deal. But for longer strings, it is going to essentially perform very poorly, and it will make your program run slower as a result. What happens when a program runs slower? What is the biggest? Who is the biggest sufferer when the program runs slower? Can you tell me what are some of the ill effects of a program that's running slow? So the biggest problem there is obviously, first and foremost, it takes time, and obviously, when it takes time, who is the sufferer? When it takes time, it is going to be, obviously we will suffer because we are essentially answerable to the people who are funding this project, right? At the same time, the key sufferer here would be the customer, right? So it may mean that your website might be loading slower. It might be taking longer to actually process your request, right? So ultimately, right, when you look at these problems, you have to look at it purely from the customer angle, right? You're actually trying to solve a problem for the customer, and how it's going to impact them would be the primary concern for you whenever you take up or solve any problem, right? So ultimately, the customer will suffer, and obviously, when the customer suffers, and then it leads to a lot of implications in terms of lost business, right? You lose money, the business loses money, right? But there is another concern here. Okay, can you tell me what it is? Apart from the monetary part, there is also another concern. Can you tell me what it is? It is something to do with the environment, right? So every time a machine runs, right, it reduces a lot of carbon into the atmosphere, right? So it is not eco-friendly at all, right? It is not a sustainable. If you look at it, I mean, I'm sure you heard about it as well. So some of the things that they are looking at these days is sustainable development, right? So there they want to reduce the carbon emissions, right? Yes, they want to reduce the carbon footprint as much as possible. So if your let's say algorithm is taking longer time, let's say O(n) squared or O(n) cube, or even let's say even beyond that, right? And that means the program is releasing a lot more carbon into the uh, emissions into the atmosphere, right? So that's not good, right? So that's also another consideration that you have to keep in mind. Okay. All right. So with that in mind, how can we reduce the complexity here is the question right now. Okay. So I'm going to discuss that here. So so the idea here is that you have to find the um, unique character. Yes, definitely. Map is one of the definitely considerations, right? But just the map will not help, because even using the map, even the O(n) square will use the map, right? Because we need to keep track uh, of characters that have already occurred, right? So so that's what it is, right? So let's actually look at this example. So we have heard, I'm sure you have heard about some concept like sliding algorithm, right? Sliding window algorithm, right? Right. So here, what happens is that this problem, right? The problem that we're looking at right now, uh, the performance it gets reduced to order of n with the sliding window, right? Which is the least that you can do, because in a situation like this where you're trying to find unique characters, you have to traverse the entire list of the characters, right? So which could be which could be, let's say, of size n. So the best performance that you can get here is order of n, right? Not any less than that, right? Because end of the day, to compute the lowest or rather the highest string length, right, you have to go through the entire string. Of course, there might be some, let's say, uh, manipulations or optimizations that you can do on top of that, but O(n) is the best that you could do. Agreed? Okay. All right. So let's take this particular string here. I'm going to take this like A, B, C, A, C, B. Let's say A. Oops. That's A, right? This is one of the string that we have, right? So in this one, we want to find the string or the substring which has the which is unique, right? Which doesn't have repeating characters, and we want to find the count of that string. So for example, another thing to note here is that we are saying substring here, right? Okay. So which means the string that we're talking about, the characters or alphabets which occur in a string have to be contiguous. Okay. Not necessarily, they cannot be in any place or in any order, right? So the ordering has to be contiguous. So for example, if I'm looking at a unique string here, so for example, let's say we start with A, right? So A is a unique string, and if you go further, B is also another. So AB is another unique string, we go further, ABC is another unique string. If we go further, we encounter A is already here. So we say the count here, right, is 3. The unique count at this point in time is 3, correct? So don't confuse it with another term called subsequence, okay? That's slightly different, right? So there, the contiguous nature is actually not enforced. In a substring, the contiguous nature is enforced, okay? Something to be aware of. All right. So with this in mind, so let's go with this example. So let's say we have found ABC, which is going to be of count 3, right? And this is going to be the unique string for now. However, when you encounter A, what happens? A is already present, right? So which means if we go here, it cannot be a unique string anymore. So what do you do? Right now, this is your window, right? This is your window, right? So this is your window, right? You started with I is equal to 0, and we are right now at we'll have another pointer, and j is equal to 2, right? So which means the string length is the j minus I, right? And plus 1, because we started 0 index, right? So which is going to be equal to 2 minus 0 plus 1, and that is going to be equal to 3, right? Making sense, folks? Are you with me? Okay, great. So this is how it is right now. However, the moment you come here, right, this place, there is a repetition, right? There is a duplicate. So we already have encountered A. So what do you do here? We actually essentially resize our window. So for example, we move the I pointer from 0 to here, right? And then all the way from here to A, right? So now I becomes 1, right? We are at 1. This is I, and this one is 3, right? Okay. So what is the applying the same logic? What is going to be the count, the length right now? It's going to be j minus I plus 1. So j is at 3, I is at 1, right? I is at 1, correct? And plus 1. So both of them cancel out. So we have a string length of 3 again. Likewise, we keep moving forward, and let's say we move forward here again, right? We encounter a C, so which means C is already here. So what we have to do, we have to, and we remember, while we do this, right, we also need to have a set, right, which is going to essentially maintain the characters that we already encountered. So for example, we already encountered A, we already encountered B, right? We already encountered C, right? So when you move here, right, because we have already encountered C, we have to go back. We have to resize the window right now. So until this character is no more in the set, right? So for example, we have C here, right? And until we encounter C in our left pointer, we have to move ahead, right? So for example, we are at B right now, right? So in order to essentially get rid of C, we have to move our pointer all the way from here to A, right? It's because we need to cancel these out right now, because until C is there, we cannot make a unique string anymore, right? So which means our window will get shifted from here to here, and this is going to be our newer window, okay, which is starting from this way. So this is going to be 3, right? Starting from 3, this is going to be our I, and j would be 4, right? So right now our string strength is 2, and right, so for example here 4 minus 3 plus 1, and this is going to be equal to 2. However, this is lower than 3, so our maximum string length is still 3, okay? But we can still continue, right? So we can go ahead here, and move on. So we encounter B. B is not present here because only we already canceled this one out, right, as part of the resizing of the window. So we can move here right now. Again, we come to, so J becomes 5, right? So it's going to be 5 minus 3 plus 1 is equal to 3, which is the same as the original max, so we don't do anything. So every time we encounter a string which has a higher length, we also need to recalculate the length, right? So we'll be maintaining a max length variable outside, max length variable outside. Okay. Let me do this. We'll be maintaining a max length variable somewhere, which will keep track of the maximum length so far, right? So right now it is 3, right? And every time we actually exit a window, we go ahead and then recalculate this max length. Okay, does it make sense? Okay, so so that's how we can do that. So essentially we'll do that for the entire string, and ultimately we come up with the max length. All right, so that's going to be the crux of this particular problem. All right, so let's go ahead and code this one out, and I think it'll make it more clear as we go along. All right. Okay, I'll go back to the IDE here. Just a minute. Okay, super. So let me go back to the IDE and start coding this one out. Yeah. Okay. So this is going to be find string tr.js. I hope particular thing is visible to you. Am I sharing the screen? All right. You can see my screen, right? Give me a moment here, folks. Okay. All right, so let's get started. I'm going to define a new method here. Let's say const find string strength for string RENGH is equal to, it's going to get a string as a input parameter, right? And there we go. It's going to be an arrow function as always, right? Okay, super. Okay, I'm going to first maintain the string strength as so the what is going to be the so the outcome or result that I want to essentially get out of here. I'm going to say, let's say, I want to essentially do the strength, right? And then I want to go ahead and then return the strength here, right? All right. Super. You're able to view my screen, all right? Can you give me a thumbs up there, please? Hello, everyone. Are you able to see my screen, all right?
So you need to slide the chat.
Slide the chat.
Slide down.
Slide
Down the chat.
Okay. Slide down the chat. Okay. I don't seem to get that option here. Oh, okay.
Sir,
All
I
right.
will scroll.
Okay. All right. My bad. Thank you. Thank you for reminding me. I was not aware. It was actually not so obvious to me. All right. Okay. Super. Thanks for that. Okay. Great. So let's go ahead and then do this. So first thing is we want to get the longest unique substring, right? So I'm going to say const unique substring, right, is equal to, I'm going to define a new method here. I'm going to say find longest unique, right, or substring rather. Okay, and this is going to get our string as well. Okay, great. So, and then once we do that, then we'll be finding the strength, right? So I can say strength is equal to, and it's going to be unique substring, rather the unique substring length. This is right. So unique substring length divided by str.length, right? And this is going to be a, this is also going to give us some fractions, right? So I can say return strength dot, I want only 2 digits and in the decimal places, so 2 fixed and 2. Okay, 2, and I'll get rid of this return part here. Okay, now coming to the meat of this problem, right, which is going to be the finding the longest substring, right? Let's go ahead and do that. Okay, so I'm going to define another arrow function here. Important again is that you have to keep your code always modular. So in case you can use helper functions where you can encapsulate a certain logic, you can always use a separate function for that. Okay, so instead of writing the entire logic in the same function, it makes the code readable, right? And it also kind of gives an impression to the interviewer that you are actually a very methodical person, right? So important to bear that in mind. Okay. So I'm going to go ahead and say find the longest unique substring, and this is going to get a string, of course, and this is going to be an arrow function. Okay. All right. Let's get started. So what do we do? First thing is we want to return the count, right? So I'm going to define. Could have done it as len. What do you think? Len is better or count is better? I cannot use len because I think that's one of the methods that's there. Can we use string len or maybe str len or something like that? String len, yeah. Okay. We'll set it to 0, right? And we also want to maintain. So what do we do? I will go over the entire length of the string first. So which means I will need a for loop, right? So I'm going to say let And also remember, I'll be maintaining 2 pointers here, right? Because it's a sliding window, we will end up with two pointers, right? One will start at the end first, and then the other one will scan through the entire list, right? And then every time there is a duplicate that has been encountered, we actually resize the window by moving the start pointer, right? So I'm going to have 2 pointers here. I'm going to have a left pointer, okay, which is going to be the start of the sliding window. So I'm going to set that to 0, okay? And I'll also have a right pointer, and I'm going to define it here in the, let's say, the for loop itself. So I'm going to say let right is equal to 0, and right is less than str.length, right? Okay, and right plus plus. All right. Okay. So what do we do? So let's first get what is the current element. I'm going to say if const current is equal to str at right. Okay. So we're going to look at the first character, or the whatever the right pointer is actually pointing to. It could be the first one, it could be the second one, depending on how big is our window size, right? Again, remember, this is going to be a dynamically sized window. There is no specific size. So certain problems in sliding window are such that the window size could be predetermined. So for example, you could be given an array, right? You could be given a problem where you want to find out which of the contiguous um, um, elements of size 3, right? So for example, let's say we have an array something like this. Let's say 1, 2, 3, 4, 5, 6, right? So we want to find out which is the combination of elements of size 3, right? Window size 3, which has the highest sum, right? So in this case, we'll be looking at 1, 2, 3. We could be looking at 2, 3, 4, and 3, 4, 5 finally, right? So, and find out the sum. In this case, this window is static. The size of the window is saying it's 3. We only want to consider 3 elements from the array, right, which are contiguous in nature, and look at the look at the highest amount of, let's say, the count of those, rather the sum of those numbers, and we want to find the maximum sum, right? So in that case, it becomes a static sized window. In this case, we are looking at a dynamically sized window, right? Because our window size is not predetermined. Okay. So, what we have to do, so let's assume that we have something like this, right? Say ABC, A, C, B, right? So let's assume that we have something like this. So first thing we encounter the, we actually process the first element. And in order to know that a certain element is processed before, we also want to maintain a set, right? Which is going to contain unique elements, right? So I'm going to say const char underscore set, which is essentially already seen in our processing. And I'm going to set it to new set, right? So are you aware what a set does? So for example, if I have something like this, right? So this is an interesting concept. I'll just go over that quickly so that there is no confusion. The set will always have unique characters, right? So let's say let chars is equal to new set, right? This is what I can do. Okay, and so I can say chars dot put, right? I think that's what the method is. I think chars dot add. Chars dot add, and I can add a character, let's say A, right? Okay. So if you look at the set, if you say chars, it will have one element. If I repeat that again, right? So let's say I repeat that, it doesn't do anything, right? It will have unique characters all the time. So similarly, I can do A, B, say C. Oops, not B, C, it's just C. Okay. So it has 3 characters. Similarly, I can also go back and check if a set has a particular character, right? So for example, I can say char dot, and there is a has method, and I can check it has a. Okay? If I do this, it says it true. And let's say if I do something like e, it should give me a false here, right? I can also do a delete. So for example, I can say chars dot delete, right? And I can delete a here, let's say. Okay. So if I do a chars again, it should only show us B and C. Okay. So this is the functionality of the set. Is that okay? Okay. All right. So coming back to this one. So now we'll be maintaining a char set here, right? So every time we encounter a, let's say, a duplicate, we need to make sure we need to go ahead and then resize our window, right? We need to reset our pointers as well, right? So I'm going to say while, and I'll be doing it at the very beginning, okay? So if our char set, right, already has current, what I want to do, I want to delete the leftmost character, right? So which is this one, which is current. I want to delete the current. So I'm going to say char set dot delete current. Yeah. Oh, I'm sorry. It is at left, not the current. It is the left one. So whatever is pointed to by the left, I need to delete the left, not the current. Will be str. Okay. Left. Okay. And I also want to move my left pointer here, right? Because we're resizing the window here. So left plus plus. Okay. And in case we are essentially done with this particular option, what we can do is I will add the current element being processed to the char set in case there is no duplicate, right? I'll say char set dot add, and I'll add the current element. Okay. And at this point in time, I will also calculate the result, right, which is the string length. So I'm going to say string length is equal to, I'll use the math function here. I'm going to say math dot max, right, and original string length, and the point, we'll use a pointer arithmetic here. So right, which is j essentially in our example, minus left, right, and then add plus 1 to take care of the zero-based indexing, right? So that's what we need to do here. And finally, we'll go ahead and return. Are we returning something here? So we need to return. Oops. Return string length, right? This is what we have to do. Okay. All right. So any questions, folks, so far? So maybe we can take a look at one dry run here. So let's assume that we were encountering this particular problem, this particular string. Okay. So initially we start at 0, right? And left is also 0. And the current will also be A, right? Since A is not current in character set, it will go ahead and add it to the current, the character set. So let's say right now, our character set is having A after processing the first element, right? And let's assume we move on to the next element. So right now is going to be at 1, right? Left is still 0. Right now, right will be 1, right? Which means we are processing B here. So we check B. Is it currently there in character set? No. So we go ahead and add it to the character set, right? Okay. Similarly, let's say we process C. It is not there in character set. It goes here, puts it in the character set. Also, it computes a string length, right? So right now, what is right? Can you tell me? What is the right pointer after adding 3? it is 2, right? And left will be 0. So 2 minus 0 plus 1, and string length will be 3, correct? Okay. So this is going to be interesting, right? Next, we'll be encountering A here, right? This is going to be A. So we come here, and current is A, and is it there already? We need to check if it's already there in the character set, right? So which means it is going to give us a true here, right? So what do? We will delete. We want to resize the window, right? So we want to move from all the way from here up to C, right? So we'll be deleting these two elements, or rather only this element, because we want to delete A only, right? So we will be deleting A, right? And then we'll be moving the pointer to left plus plus. So which means our left pointer will be at B here. Okay. And then once that is done, we move left plus plus, right? And yeah, so and then we add the current, yeah, which was actually in this case A. We add A again to the set and then recompute the string length here. All right. Any questions so far, folks? Any thoughts? Before we start running this program for correctness, of course. Any questions, any thoughts, any clarifications? Okay, great. That's good to know. So let's go ahead and run this program now. And hopefully, let's check once more if we are doing okay here. So we have left is equal to 0. All right. And sometimes, we can end up writing right here, which can lead to very strange results. It could be a typo. It could be a suggestion from the IDE. That's one problem with the IDE suggestions, right? They may not be always correct. Okay. All right. So I'm going to go here, then invoke this particular function, right? So let's actually take the example from the okay, I don't know if there was any example. So let's actually try something, right? So let str A B C B C A. Right? Let's try this. A. All right. So here, what would be the answer here? Can you tell me what would be the string strength here? String strength would be 3. No. String strength. So the longest string here would be, longest unique strength would be what? It would be 3 here, right? The longest would be 3. Unique string would be 3. And 3 divided by 7, right? So essentially 3 divided by 7, right? Agreed? It should be 3 by 7, right? Okay. All right, let's go ahead and give it a shot. I'm going to exit from here. Okay, so let me see where I am. I think I need to go to SRC here. SRC here. Okay, there we go. So I'm going to say node find string strength, right? That's going to be 0.43, which is about right, correct? Yeah. No? Why do you say that? Say that, Aradhya. Why do you say that? Yeah, I think it's actually rounding up. That's why you might be. So for example, if I don't do this right, it will probably give a different answer. So if I do this, it'll give you this, right? So it's rounding. It's rounding up, right? It's 4.42, but there is an 8 here, and it's rounding up here, right? That's why it could be a confusion here, right? Okay. So this is the string strength problem, right? And yeah, first problem, of course, for today. Any questions so far? In case there are no questions, we can move on to the next set of problems here, right? We got some interesting problem here too. A problem. Okay, can we move on to the next problems? Let me know. Give me a thumbs up if you think that's okay. Yeah, the one that we looked at right now, it's a starting window problem. Yes, that's correct. And obviously, this is going to be, what's going to be the time complexity here? We forgot about it. So if I have to say time complexity here would be order of, do you want to tell me what's going to be the time complexity here? It would be order of n, right? Okay. Yeah, either that n or this n. Either way, it's fine. And what about the space complexity? You tell me. What is the space complexity here? First of all, is it yeah, actually it is order of n, because worst case we may have all characters unique, right? So which could be on, right? So it's order of n as well. Okay. All right. So let's move on and to the next set of problems, right? Actually, the last couple of days were a little bit hectic for me at workplace, so I didn't manage to. But over the weekend, I will do that. Okay. Unfortunately, I couldn't get time to push that code because there was a lot of other things that I was looking at, and apparently that came in the way. And because tomorrow is a holiday, it should allow me to spend on some time on that. Yeah. Okay. All right. Oops. Okay. So let's move on then. So I'm going to make another folder here called a part 3. Okay. All right. So folks, this is actually 9:10, right? When do you want to take a break? Do you want to take a break now, or you want to discuss this particular problem and then take a break? Up to you. You want to solve one more problem and then take a break? Is that okay? All right. Let's do that. All right. So here is the problem, right? So okay, great. So this is the first problem for today. So we have a tray of eggs, right, which contains eggs in different placeholders. Your task is to find all the empty placeholders in the given tray. Okay. So essentially, this is going to be a 2D array of m by n size, right? and each cell can contain either a 0 or 1. So this is going to be a binary matrix, right? 0 represents an empty cell, 1 represents an egg present, right? So what is going to be the output that we want to do? We want a number of empty cells in the given tray, right? And there is also another input here. Each row and column is sorted in the given array. This is going to be important to solve this problem. Okay. This is going to, the whole problem solution is going to be revolved. It's going to revolve around this particular statement. Okay, this is very important. And actually, they should have given it in the problem statement itself, but they have given it as a note, which is no, I didn't get that question, Aradhya. Can you elaborate that a little bit? Extra space for what? You can actually, speak up if you think that it's going to help. Because you can unmute yourself and speak. That should be fine too. Can you unmute yourself and then speak? That's fine too. Because I think in Google Meet it allows you to do much more freely. No space. No, it just says that the output, the input here, right? It is sorted in the given array, right? If you look at each row, it is sorted. If you look at each column, it is sorted, right? That's what they're saying. Okay. All right. So let's actually go back to the whiteboard, right? And take a look at it. Okay, there we go. So we are given an array, right, which is going to be something like this. I find it so difficult to actually draw a straight line on this whiteboard. I don't know, it's something to do with I need to practice this a little bit more. 0, 0, 1, 0, 1, 1, 0. I'm just taking an example from the book, right? Okay. So if you look at this particular thing, right, a 0 indicates an empty tray, empty cell. 1 indicates an occupied cell, right? And it also says that we need to find out the total number of empty cells here, right? So in this case, what is the number of empty cells here? This is going to be 4, right? That's going to be the answer that you should get here, right? So there is another interesting note they've given, even though it is actually as a side note. I would have liked it to be part of the actual problem statement itself. So here, what they say is that each row and each column is sorted in ascending order, right? So if you look at it right now, let's consider row 1, right? This is starting from here is actually sorted in the ascending order, right? Similarly, this is R1, this is R2, this is R3, right? All of these are sorted in a ascending order, right? Similarly, if you look at the columns, right? If you look at column C1, this is also sorted in ascending order, right? This is also sorted in ascending order. This is also sorted in ascending order, right? So C1, C2, C3. Yeah. Okay. So how can we use this particular problem, particular characteristic of the matrix to solve this problem, right? So when you say something is sorted in in the matrix is sorted, right? So we can say, so let's actually redraw this matrix. So 0, 0, 1, 0, 1, 1, 0, 1, 1. Right? So when this particular thing happens, right, we can say that we can find a midpoint here, right? So for example, let's consider that we can consider the top rightmost column as the midpoint, right? So let's assume that this is our midpoint. Okay, so when I say the midpoint, anything, if we go to the left of this, all numbers will be either less than or equal to that, right? However, if we go from here, and the same thing here, right? So let's say if there is a 1 here, the next numbers have to be either a 1 or a 0. However, if you encounter a 1 here, this number can be either a 1, it cannot be a 0 because it's sorted, right? It cannot be 0. So if you traverse from here, right, these numbers cannot be zeros, right? Similarly, if you are here, the number here cannot be a 1. Number left to this particular thing, right, which is at let's say this is right now at 0, 1, right? This is the coordinate. So 0, 0 cannot be a 1 because it's sorted. We already know that, right? Similarly here, if I encounter a 1 here, the next number can either be a 1 or a 0, right? Depending on what the previous number is, of course. Okay, so we can go ahead and use that particular problem, right? So we can make either this as our starting point, which is going to be the first row and topmost, rightmost column, right? Element, right? Or we can also make this as the starting point. So for example, if you consider this one, right, which is going to be our bottom row and first column, right? The leftmost column and the bottom row. If you look at this, any number which is going to be to the right will always be greater than this. It cannot be less than that. Similarly, any number above this, right, will always be greater than that, right? So for example, if I consider, let's say this number, right? So 0, 0, 1, 0, 1, 1, and 1, 1, 1, let's say. Okay, what happens here? If you look at this, if you consider this one, right, as the midpoint, anything to the right is always going to be greater than or equal to this number. Anything above will be either less than or equal to this number, right? And anything to the right, it is out of bounds. Anything to the left, it's going to be out of bounds. Anything to the bottom, it is going to be out of bounds, right? So we can use this particular property to find the number of 0 elements here. Okay, so important thing is to actually identify this particular characteristic and then look at the solution. So let's actually come to the okay, all right. So this is our given array, right? This is our given array, right? So we are sure that the rows, right, each row for that matter, and each column is sorted, correct? So when we do that, we can, let's say, assume that this is our starting point, let's say. This is our middle point, let's say, right? So I know that if I go to the left, the numbers to the left are always going to be equal or less than this, right? Similarly, if I go down, numbers down will be always greater than or equal to this particular number. Here, it will be less than or equal to this particular number, right? However, if I choose this one as the starting point or my midpoint for that matter, what would happen? The numbers above will be less than or equal, and numbers to the right will be greater than or equal, right? Okay, so that's going to help us devise a solution for this particular problem. Okay, so let's get started here, folks. Yeah, so I'm going to take the same array. So this is going to be 0, 0, 1. Actually, let me go to the very right, so that way we'll have more space. So let's say this is our array, right? 0, 0, 1, 0, 1, 1, 0, 1, 1, right? Okay. So let's assume that we take this as our starting point, right? So where, what is the coordinates here? This is going to be 0th row and second column, right? Okay, our ij value. Let's assume that I is the row and j is the column. So we are at 0 and 2, right? So what is the value at this particular position? It's a 1, right? So which means anything that is to the left, right, it is going to be less, right? And anything to the bottom is going to be always more than or equal. So we don't want to consider ones here. We only want to consider zeros, right? So we want to go to the left now, right? So what do? We decrement the column here, right? So we'll go here. So now, so this will become 0, 0, 1, 0, 1, 1, 0, 1, 1. So right now, our pointer will be here, right? Which is going to be 0, comma 1, right? Okay. So we essentially decremented our column, right? We made, so j minus minus here, right? That's all we did. Yeah. That's why 2 became 1 here. Okay. All right. So now, what is the value at this particular position? It is a 0, right? Which means we have to add it to our count value, correct? Right? So, so since we have a 0 here, we also expect zeros to the left of it, right? Correct? So what will be the number of zeros in case we want to count that? So right now, including this, the number of zeros is 2, right? So how can we derive that? We can say count is equal to j plus 1, right? J is 1, right? And so anything that is to the left is also going to be a 0. So we'll say we have found out 2 zeros in this particular row. Okay? All right. So right now, count is equal to, it's going to be how much? 1 plus 1, and that's 2, right? Okay. When I say count, it's a count of zeros, right? So once we find a 0, what we can do, we do not want to go further anymore because we have already counted the zeros for this particular row, right? So what we can do, we can move to the next row, right? So we can say this will lead to, okay, I may have to use this one here. 0, 0, 1, 0, 1, 1, 0, 1, 1. So now we are at this position, right? And we essentially incremented the count value, right? So there is no point moving forward here, right? Because we've already taken care of the count of this particular thing. So we'll move to the next row, right? So which means we will increment our row, right? So we'll say I plus plus, right? So our position will be now how much? This will be at position of 1, 1, 1, 1, right? All right. So right now we are here. Okay. So what is a so here the value is 1, right? So the moment it's 1, what do? We do a j minus minus, right? We essentially decrement the column. So the column moves to here. So what happens here now? It is going to be 0, 0, 1, 0, 1, 1, 0, 1, 1. So what's going to happen here now? What will be the pointers now? So we were at 1, 1. We're going to decrement j. So we're going to come here, right? This is going to be how much? 0 and 1, right? We'll come here, right? Okay. So at this point, we encounter a 0, right? So what happens if we encounter 0? We increment the count by is equal to count plus existing count plus j, right, plus 1. So what happens? Existing count was 2. J here is 0 plus 1. So the count here right now is 3, right? Okay. So after this, what do? From here, there is no point going to the left, right? The moment we encounter 0, there is no point going to the left. We come down. Okay. So what do? We actually go ahead and increment the row, which is going to be I++, right? So I now would be how much? Will be 2, right? Okay. So I will be 2 and B, 2, 0. So this will lead to this position right now. 2, 0. 0, 0, 1, 0, 1, 1, 0, 1, 1. Okay, so we are at this position right now. Oh, I'm sorry. I'm at this position. At this position, right? So what is the value here? This is a 0 again, right? So what do? We actually go ahead and say count is equal to count plus j, right? Plus 1, right? So it's going to be 3 plus 0 plus 1. So it's going to be 4. And after this, what do? We don't want to go to the, because we encountered a 0, we don't want to go to the left, we want to go to down, right? So we can say I plus plus, right? So what would I plus plus be now? It is going to be 3, right? You were saying j plus 1, why would that be? Oh, that was in a different context, I think. Okay, all right. So right now I is equal to 3, right? But we don't have any bounds for I at 3, right? It's actually going out of bounds. So this particular thing will only run until our I value is less than the number of rows, and j value is less than the number of is greater than 0, greater than or equal to 0, because we are starting j from a higher value, right? And we are incrementing rows, we are decrementing rows, we're decrementing columns, right? J always had to be less than, greater than or equal to 0, because there is a possibility it can go below 0 as well. So we need to take this into consideration. Okay. All right. So let's look at the complexity here, right? So any guesses for the complexity? Log n. Okay. Why do you say that? Why do you say that? We are not halving it, right? So only when we are halving the entire array, then we would it'd be a log n, right? So here we are actually going through each row and each column, right? So essentially, we are touching each row and each column, right? So assuming that we have m rows, m rows and n columns. So since we are touching each row and each column, it would be m plus n. Okay. All right. Okay, so let's go ahead and then look at the implementation, and then we'll take a break for dinner. Yeah, make sense? All right. I'm gonna go back to my coding IDE here. Okay. Super. Okay. Let me minimize this a bit. Let me go to part 3, and I'm gonna start. So this is going to be count empty spaces, right? That's what it is. What is the problem actually? Count. Okay. All empty placeholders. Okay. Just call it count. Count empty spaces. Okay. Okay. So const count empty spaces. The function and can get a matrix. Right? Okay. And this we can get rid of this additional parentheses because it's only a single argument, right? Another style of actually doing programming. So first, I'll say let count is 0. I'm going to go ahead and return this count. All right. Okay. All right. So next, I want to, what do I want to do? I want to find out the bounds of this matrix, right? So I'm going to say let m is equal to the number of rows, which is going to be matrix dot length, right? And let n is going to be the number of columns. It's going to be matrix, and I'm going to say matrix 0 dot length. Okay. And we're going to be starting at, as I mentioned, at the midpoint. So for example, if I go back to this diagram here, we'll be starting from here, right? We'll be starting from here and then moving backwards or downwards, right? You could also start from here and then move upwards or to the right, but we'll essentially look at that problem at in another instance. But for this problem, I want to start from this place. Okay. All right. Okay. Okay, let's go. So I'm going to say, so I'm going to maintain two more variables here. I'm going to say let row is equal to 0, starting point, starting row, first row, and let call is equal to n minus 1, which is going to be the last column. Okay. So I want to essentially process this matrix until we don't go out of bounds, right? So for example, while a row is less than m, right? And call is greater than or equal to 0, right? Right. So what I want to do, if matrix, let's actually process the current element, right? So I'm going to say const current is equal to matrix at row and call. Okay. So I'm going to say while current is equal to 1, what do I want to do? I want to essentially move to the left, right? Okay, somebody's trying to join the call. Sharath Patel, is he your classmate? Folks, can you confirm? Hello. Okay.
Yes, sir. He
Okay.
is.
All right.
You can accept
All right.
him.
Sure. Okay, let's move on to the code. Okay. So while, so going back to the drawing board here, right? So when this is 1, you want to move towards the left, right? So while the current is equal to 1, you can say we want to decrement the column, right? Okay. In case it is not, what can we do? We can increment the count, right? So we can increment the count to what? Count plus equals column number plus 1, right? And you also want to go ahead and then increment the row. Okay? Yeah, it's quite simple actually if you really look at it, right? So yeah, and finally we actually process it until the end of the until we have reached the bounds, right? So we're returning the count here. Okay. Any thoughts? Any questions so far? Okay, I think I need to scroll down. Can we go ahead and run this program if there are no questions or clarifications? Where am I? Okay, there. Maybe I'll just command prompt. Okay. This is going to be part. Okay. Okay. Should have made it SRC. Maybe I should. Okay. So I'm going to say no. Okay. I need to give it some input as well. So let's go ahead and do that. Let input is equal to. So I'll use the same input that we got, right? So this is going to be 0, comma, 0, comma, 1, right? And we'll just go ahead and then hit this. Okay. And so log. Okay. What is that? Count empty places, right? Count underscore empty places and input. Okay, let's see what we get here. Yeah. So node count empty places. It's going in a loop, I think, interestingly. Why would that be? So row plus plus okay, let's actually do a little bit of console logging here. I'm going to say console log row, comma, com. Okay. So I could do the same thing here as well at each, say, matrix at row, comma. Okay. Okay. Think was this the problem? I don't think so. Anyway, side while. Okay. It is going in a while loop or infinite loop. Interesting. Why would that be the case? Com minus minus. One, two, three. Okay, it's not coming out of this one, fortunately. It's going to row 0 in column 2, and that's it. It's just stuck there. Interesting. Current is 1. Okay, that's current is 1, yeah. We have to. Okay. Let me give it a more shot. Why is it? Oh, it's stuck in while loop. Interesting. Okay. Stuck in a while loop, all right, but I'm decrementing it here. So it should actually go to the next one. Any thoughts, folks? Do you think something is missing here? It'll be straightforward, actually. Well, it's equal to n minus 1. Current is equal to this. Or is it stuck? Yeah, which while? Yeah, I know that it's actually getting stuck here, and yeah, Aradhya, allow me to fix this problem first. So, and then we'll come back to the actual explanation. So let's see. Is less than n. Let's actually say n, comma, n. Okay, so it goes very fast actually. Mm-hmm. Side while too. No condition, but it's not even exiting the inside loop. Second, no condition. Current is the condition, right? Let's say call minus minus, right? Okay, I see what you're saying. Yeah, I see. Yeah, you're right. It just keeps on decrementing call minus minus. Doesn't go out, right? Okay. All right, I see what's happening here. Okay. So I think let's do this now. We will actually break for dinner. In the meantime, I'll just fix this problem and then we'll come back and then continue. Is that okay? I think that will be a better use of your time. Okay. So let's break here for dinner, come back and continue. Yeah. Okay. All right. So what time you want to be back? It's 9:48. 15 to 20 minutes, which is what time? 10 o'clock? 10:05? 10:10? Okay. All right. We'll be back by 10:10 then. Okay. In the meantime, I'll also have enough time to actually sort this one out. Yeah. All right. Talk to you soon. Bye. Yeah. Oh. Okay, Jana. Problem with the ticket you. Okay, finish that. Shortlist distribution problem. Summarize the whole lineage. Hello everyone. Can we get started, or you want people to come back? Okay, let's start at 10:10. Hello everyone. Okay, so thank you for the confirmation. Let's get started then. Okay. So I'll go back to the code base that we earlier had. Okay. So this one, right? So as someone is pointing out, okay, allow me to share my screen as well. Share screen. Okay, can you see my screen? Okay, great. So so right now, as someone was saying, right, this did not have an exit condition, this while loop condition, which is correct. So actually what I did was I assigned this to a current value. And essentially, what would have ideally helped here is that using, instead of current, to this one, right? So this way, it'll have something to look at, right? So essentially iterating on something, the condition itself was not allowing us to iterate and exit at an appropriate point, right? So that was a problem. So I went ahead and then fixed this issue. Let's go ahead and fix this problem, run this problem one more time, okay? So I'm going to say count empty places. Actually, we should have removed, yeah, there we go. It says 4, which is the correct answer. I'm going to go ahead and remove these things. So it's makes it more readable. I think, yeah, sure. I don't think we need this one. It's more of a readability thing. Okay. Yeah, I think we're good here. Okay. Run this again. Yeah, and we go. We get it 4, which is the correct answer, right? So if I go ahead and then make it 0, give us a different number. Yeah, we do. How about this one? If I do 0 here, give us a different number also. Okay, super. It's looking good right now. Okay. Any questions? Somebody was asking me to explain this code one more time. Not sure you still want to do that, or we can move on to the next problem. Are we good to go or to the next problem, or? Explain after. I didn't get that. Can you elaborate what you're trying to ask? After move on. Specific point in the code? Okay, sure. So let's assume that we have some, let's take it with an example, right? I think that will be helpful. So here, oops. Okay. Let's try to explain this with an example, right? So I'm going to have a matrix, something like this, right? Say 0, 0, 1, or 1 rather, yeah. I'm going to go ahead and then get this. Make it 1, and this also has to be 1, right? This is the example that we're looking at, right? So let's assume. So what we're trying to do here, right? We know that this is sorted in row-wise fashion. It is also sorted in column-wise fashion, right? That part is known, right? So what we can do is we can look at the rightmost element, topmost right element, or the bottommost left element as our starting point, right? Because that will allow us to essentially scan through this matrix in an efficient way, right? That's why we are trying to do that. So which means if we start from here, anything that's to the left is going to be less than or equal to this number. Anything to the bottom is going to be always greater than or equal to this number, right? So with that, we will start at this position, right? So let's say row is 0 and column is 2, right? So here it is within the bounds. So we say if the element at 0 and 2, right, is equal to 1, what do? We decrement the column, right? So column comes here right now, correct? Okay. So and then we go to the next iteration, right? So right now the matrix at 0 and 1 is not equal to 1, so it comes here. Okay, all right. And so what we do, we increment the count to the column plus 1. So column right now is 1, however it is 0 indexed, so we add an additional 1 to that, so count becomes 2. And because this is 0, we want to go to the next row, right? We want, because there is nothing more to cover here because already taken care of the count, we go to the row, next row, which is row plus plus, right? So now we are at position 0, I'm sorry, 1 and 1, correct? So now 1 and 1 is a 1. So we do what we do, we decrement the column again, so which means we come to 1 and 0, right? So 1 and 0 is a 0, so which means we increment the count, so it is going to be 2 plus call plus 1. Call is 0 plus 1, so it's going to be 1, it's going to be 3 now. So, and also we actually go ahead and increment the row, right? So which means our pointer will be at 2 and 0 now, right? So which is within the bounds. So we come back here, look at whether it's a 1. It is not. So we come here, increment the count and increment the row as well. So now our row is 3, right? And now we come here, row is not less than m, right? So we go ahead and exit this loop and then return the count here. That's what we do. Okay? Are we good? Okay, super. So let's go on to the next problem then. Okay. I'm going to go back to the PDF here. So the next problem is a ticket queue problem. This is, again, there are multiple train ticket counters and there are long queues in front of each counter, right? And tickets are given to each person in the queue, right? And each ticket will contain some number. Your task is to find the sum of numbers on the ticket in each queue. All right. So they say this is an m by n size number, m by n size matrix, right? Where m is the number of ticket counters and each column will represent the queue on the customers, right? So essentially, there are 4 counters here, and there are 4 people in each counter, right, in the queue. However, it could be more, right? Generally, it is going to be more because if you go to, let's say, a railway station to book a ticket nowadays, of course, you mostly do it on, let's say, the IRCTC, right? So you don't have to encounter this. But earlier, you would, if you went to a railway station, you would find long queues to book a ticket, right? So in such a case, they would have a limited number of counters, but lengthy queues, right? So what they're trying to say is that each person has a ticket and it has a certain number, right? So we want to essentially sum up all the numbers in each queue and then render the output as individual counts, right? So for example, in this case, the output would be something like this. So in this case, say 10 plus 15 is 25, plus 24 is 49, plus 32 is 81, right? So we are getting 81 for the first column, right? Yeah, it's column-wise addition. Yeah. So yeah, relatively simple. I don't think it's a whole lot difficult, but yeah, let's go ahead and then try to get this done. So we're good with the understanding of the problem, right? So we essentially traverse this particular thing in a column-wise fashion, right? Find the count, right, or the sum, and then we essentially store it, right? And we do that for each of the columns. Okay. All right. So let's go ahead and then code this in. I'm going to go back and bring up my IDE. Okay, there we go. Okay. I'm going to create another file here on that count. It's per queue. Count tickets. I think that should be enough, right? Maybe I'll make this function a little more descriptive. So I'm going to say const count. It's going to be a arrow function. Okay. So what we'll do, we will actually maintain some result object which will contain this particular output, right? So I can say my result object will be a array. Okay. All right. So I'm going to be going over each of the rows and each of the columns, right? First. So I'm going to say const m is going to be the number of rows, right? That's going to be matrix dot length. Okay. Similarly, I'll say the number of columns here would be it's going to be n, total number of columns, that is, right? So I want to go over this in a column wise fashion, right? So I will say initially my initial column is going to be at 0. So I'm going to start at column 0. Let col 0. Okay. While so I'd have first external loop which will essentially control the column, right? So I'm going to say col is less than n, of course. Right? And we can go over the rows in a essentially from the top or from the bottom. That's not a problem. So let's actually go initialize the row here. So I'm going to say let row is equal to m minus 1, right? We'll start from the bottom. Okay? And we'll also maintain a variable for column sum. So I'm going to say let col underscore sum is equal to 0. Okay. Right. So while row is greater than or equal to 0, because we don't want to go beyond that, we have to be within the bounds, right? The column bounds and the row bounds, right? Because we are starting at the last row, we will be checking the row as greater than or equal to 0, and we'll be essentially doing a decrement of the row here as we process each row. Okay, so I'm going to say const current is equal to matrix row and column, right? Okay. And I'll say call sum plus equals current. Okay. And after processing this row, what I will do, I will just go ahead and decrement the row now, right? So right now, I'll be moving to the next row, which is the previous row. Okay. And at the end of this loop, when I have finished processing all the rows, I will get the column sum, right? I will go ahead and push this to the result object. So I'll say result push all sum. Okay. And not to forget, I'll also go ahead and increment the call itself. Otherwise, it'll lead to an infinite loop, right? Then finally, I go ahead and return the result. I think that's what we're doing here, or we are not. Go ahead and say return. Okay, super. There we go. Super cute. Any thoughts? Any doubts? I think this was quite straightforward in my opinion. So we can go ahead and then essentially execute this code, right? So I'm going to say let matrix is equal to with the same input that we have, right? So let me go ahead and then give that input empty 30 40 15 25 35 25 24 29 37 48 then 32 39. Okay, so I hope more 10 20 30 15 25 35 45 24 29 37 48 32 33 39 and 50. Okay, so I'm going to say console log. Not sure what the method was here. Count tickets per queue. It's actually ticket value. Actually, tickets value. Okay. All right. Super. Okay. Let's go ahead and then execute this one now. Okay. Let's say node. Yes. Okay, there we go. Console is not a function. Okay. I missed the log here. Okay, I think that's about right. Okay. That's all that we need here. Yeah, again, this is going to be order of n by n, right? The time complexity. I don't think there's a whole lot to think about. It's order of n by n because we're essentially traversing each column, and then in each column we're looking at each element in each row. So that's going to be order of n by n, and the space complexity is order of n, which is the number of columns, right? Okay. All right, so let's move on. Any questions? Any thoughts? Can we move on to the next problem? Okay, so then, so I'm going to go to the next problem in case you have no other clarifications. All right. Okay. All right. So let's move on to the next one. I think, yeah, this is one, right? So in a class, students, we are students are sitting on chairs which are arranged in the form of a matrix. So chocolates have been distributed to each of them in such a way that in each row and column, the number of chocolates are in increasing order. Okay. You'll be given a matrix which is an arrangement of students having a number of chocolates and a number k. You would need to find the kth smallest number of chocolates which a student can have. Okay. All right. So let's actually look at this problem. So we have, it is a kind of similar problem that we, the egg problem, right? But obviously it's with slightly more complexity, of course, right? So I'm going to go back to that. So 10, 20, 30. Let's actually take this example, right? So this is actually the same thing, right? It is sorted in ascending order in row-wise fashion. So if you look at this this data, right, it is sorted in row-wise fashion. It is also sorted in the column-wise fashion, right, for all columns and for all rows, right? If you see, so that is the nature of the problem that we can use to solve this problem, right? So I'm going to go ahead and take a similar data, right, and then explain that here. Okay. All right. Okay. So I'm going to take a similar data here, right? So let's say we have this data, which is 3, 7, 9, and 4, 8, 11, right? And 6, 9, and 12. Okay, so we're given a matrix here, which is sorted in ascending order, right? In row-wise fashion for all rows, of course. And it is also sorted in ascending order for all columns as well, right? If you go from column 0 to column to the last column, you see that it is actually sorted as well. Okay, so what do we have to find out? We would be given a value k, right, which could be a number from 0 to, I think, the number of elements in this particular matrix. So let's assume that k is equal to 5. Okay, and we are required to find out the kth smallest element in this particular matrix. Okay, so if, let's say, I had a singular element here, right? So for example, I had a single dimensional array, right? So let's say if I had to convert that here, what that would be? So we would have 3, 4, 6, 7, 8, 9, 9, 11, 12, right? This is going to be this single dimensional array, right? Okay, so what would be the kth smallest element here? What is the smallest element here, first of all? Which could be at position 0, right? This is going to be at the smallest element, right? And this would be the next smallest element. This would be the next smallest. This would be the next. This would be the next. So if I say, if I want to look at the kth smallest element here, right, that would be essentially either, you can say, let's assume that this is going to be, this is named as ARR, which is going to be array, right? So the case smallest element would be, since we started 0 indexed, right, that would be array at k minus 1, right? That's one way of looking at it, right? Which is going to be array at 4, which is the 5th position, and that in this case is 8, right? So that's how we would arrive at it if it was a single dimensional array, right? However, it is not the case. So which means, we may have to look at it slightly differently, right? So that's one part of it. So another thing, so let's say, what is the length here? This is 9, right? Yeah, that's another way of it. So it could also be array, okay? And the length of the array. So let's assume that the length of the, what is the length of the array? Minus k. We could also do it like this. So what is going to be the array length here? It is 9, right? And k is 5, right? This leads to array at 4, which is the same as this, right? That's another way of looking at it. Okay. All right. So this is the single dimensional array, but how would you do it with this particular setup right now, where we have a multi-dimensional or two-dimensional array, right? How do we do that? So how would you do that actually if this problem was given to you, right? How would you do this? Brute force. Any thoughts? Okay. All right. All right, that's a good idea. So essentially, you will process, okay. All right. No, they're already sorted. Each row is already sorted. So you have to merge them. So you have to process each row and then merge them, right? And essentially convert that into a unidimensional array, and then that would be a straightforward problem, right? So the merge sort is where would be the majority of the complexity that would be involved, right? So something like a heap would be handy here, right? So essentially you will look at each row and add the first, let's say, elements of each row, right? And then look at the next element of that particular row and then keep on adding them, right? So that's what you would do. So a heap would be a great solution here, min heap, right? That would sort them, of course, but and of course, if you want to get the 5th element, right, then you have to essentially remove the elements from the heap until k is equal to 4, right? That's where you will find the kth smallest element, right? Okay. However, that's going to be an expensive solution, so we want a more optimal solution here, right? So what can we do is the question. So because we know that this array is actually sorted, right? We can generally, when something is sorted, what can we do here? We can use something like a boundary search, right? However, if you look at it, boundary search is typically good for, let's say, a single dimensional array, right? But not for a two-dimensional array, right? So we need to be aware of that, because in boundary search, what happens? We have a, let's say, a sorted array like this, right? 1, 2, 3, and 4, for the sake of examples. And we will essentially take the starting element and the end element, right? And we calculate the mid, right? And we keep on checking if mid is equal to the actual input, right? If this is true, then we say found and exit. In case it's not, we continue to essentially look through that particular array and slicing the chunks of the search space itself, right? So initially the search space is this, and if I give 2, then the search space would be only this. If I give, let's say, 5, it would be here. But eventually, if 5 is not here, then it will result in a no found solution, right? So we cannot employ this kind of a thing because this is all based on the index. Because here we cannot use the indexes, right? Because it's not a single dimensional array. Okay. However, we cannot use the index space, right? Because it is not feasible to do that, right? Index space cannot be used. However, we can use the number space, right? So essentially, we can say this is our lowest number. The one here at 0, 0 is our lowest number. And this is going to be our highest number, right? So it's just going to be n minus 1. And in this case, also n minus 1 because we have a square matrix, right? So this is our highest number. And this is our lowest number. So we can start with s as this. We can start with n as this. And then we can find a mid of this number. So for example, I can say the mid here would be 3 plus 12 would be 15, right? 3 plus 12 is equal to 15, okay? And divided by 2, and that would be 7, right? So again, this number may be here in this matrix or may not be here in the matrix, okay? Important to know. Okay, so let's say we get this as the middle number, right? But however, so after finding this, what we can do is we can check if the count of numbers which are greater than or equal to 7, what is the number of elements which are greater than or equal, which are less than or equal to 7, right? That's what we want to do, right? In this case, it is 4, right? So we have 7, 3, 4, and 6. There are 4. However, our k value is 5, right? So which means we need to search in the upper space, right? In the higher space. So in order, while also doing that, we find the new bounds, right? So in this case, in this case, we'll say largest number less than or equal to mid, right? So what is the largest number less than or equal to mid here? It is 7, right? It is 7. And we'll also find the smallest number greater than mid. And what is that? That's 8, right? That's 8. And because the value of count is less than k, we need to search, we need to essentially reset our starting and end points. Initially, what was the starting point? Starting was 3 and ending was 12, right? Now we need to essentially move our starting to the largest element, which is essentially greater than the smallest element, which is greater than the mid, so which in this case is 8, right? So what is going to happen here? I'm going to go so our mid here, what was our mid here? Okay, actually, let's start afresh. Okay, let's start afresh. I think that will really help us here. So let me redraw this again. So we have 3, 7, and 9, 4, 8, and 11, and finally 6, 9, and 12, right? Okay, super. So here, initially, this is our starting point, and this is our ending point, right? Okay. Now, what we want to do, we want to find the midpoint, right? So mid here would be how much? 3 plus 12. This is going to be divided by 2, and that's going to be 7. All right. So what is the smallest number which is greater than 7? Greater than 7. That's nothing but 8, right? In this case, it's going to be 8. All right. What is the largest number? Less than or equal to 7, or rather mid, right? And that's nothing but 7. And we also want to know the count of numbers, right, which is less than or equal to mid. So count of numbers less than or equal to mid. This is equal to, right now, mid is 7. We are having 4 numbers which are less than or equal to mid, right? So this is going to be 4. However, we have a value of k which is set to 5, right? Let's assume that we have set it to 5. So which means we want to find the 5th smallest element, right? So, but however, we don't have the count doesn't match 5, right? So which means we have to search in the higher number space, right? So what do? This will lead us to the following situation. So I'm going to say, so this is 3, 7, 9, 4, 8, 11, 6, 9, and 12, right? Okay. So now, because k is essentially greater than this count, right? We need to reset our starting and end points, right? So we have to move from starting endpoint to the upper space, essentially, right? Just like we do in boundary search, right? So I'm going to say now start is going to be equal to 8, because that's the smallest number greater than or equal to 7, and end will still be equal to 11. So this is going to be start, this is going to be end. Okay. It's going to be 11. Okay. All right. So now what is going to be the mid? This is going to be 8 plus 11 divided by 2. That's going to be 19 by 2, right? So that's going to be 9, correct? Mid is going to be 9, right? No, I'm sorry. End is actually 12. I made a mistake here. End is actually 12, because this is what it is, right? 12. So end is 12. This is 12. So this is going to be 10. Okay. All right. Remember, this mid need not be in the number space at all. Okay. It's perfectly fine that it is not in the number space. It's just there as an indication to either to search in this half, right? So right now in this half or in this half, right? Based on the mid. Okay. All right. Now similarly, we'll say what is the smallest number greater than 7, greater than mid, right? Which is going to be which is going to be 10, right? And that's nothing but, what is the smallest number greater than mid? It's not 8. It is 11, right? Okay. And what is the largest number? Less than or equal to mid? What is the largest number less than or equal to mid? Mid is 10. Largest number less than or equal to mid is going to be 9, right? Less than mid, that's going to be 9. That's going to be 9, right? Oh, you're getting confused, actually. Largest number less than or equal to mid. Yeah, it's slightly confusing. It's 9. Okay. All right. And what is the count of numbers? Okay. Less than or equal to mid? So what is the count less than or equal to mid? Mid is right now 10, right? So we have 1, 2, 3, 4, 5, 6, and 7, right? That's 7. However, our k value is 5, right? What is our k value? This is more than k. So we need to search in the upper space now, right? So let's do that again. So this is going to be 3, 7, 9, 4, 8, 11, 6, 9, and 12. Okay. All right. So what was our search starting point? It was actually S, right? And so now we need to reset the endpoint, right? It was earlier 12, right? So we can set it to the largest element less than or equal to mid, right? So which is essentially 9. This is going to be our endpoint, right? Correct, right? It could be either this 9 or this 9, doesn't matter. Either of them. There are 2 9s here. This could be either this 9 or this 9. Okay, I took this because it's earlier. Yeah, you never know which one is earlier here because anything is fine here. Okay. All right. So now, what is the mid? Let's compute the mid. 9 plus 8 divided by 2. That's going to be 8, right? Correct? Right? And the smallest number greater than mid would be how much? 11, right? Largest number less than or equal to mid. How much that would be? Mid is 8. Oh, hold on. Mid is 8 here. Smallest number greater than mid is not 8. It is actually 9. My mistake. Okay. Largest number less than or equal to mid is going to be 8, right? Are you with me? Okay. Finally, the count of numbers less than or equal to mid is going to be how much? So we have 8 as the mid. How many now? How many numbers do we have here which are less than or equal to 8? So we have 8, 7, 3, 4, and 6, which is 5, right? And this is equal to k. So which means our kth smallest number is 8. Okay. All right. Did that make sense, folks? Or was it a lot of information to take in? Okay. All right. So do you want to, so here's what I would suggest, right? Can you go through this video recording and before coming to the next class, and then we'll come back again and then do the coding part? Because if I do the coding part right now, I think a lot of it will really be, you know, it'll not be very obvious to you, in my opinion. I think what will help is if you go through this recording and come back on Monday, and then we'll do the coding. The coding will also become faster that way, because and then we'll also explain it one more time, because some of the students would have missed this class, right? So we'll take about 10 minutes to explain, and then start out with the coding part as well. What do you think? Does that make sense? Okay. So I think, yeah, I think it follows a similar pattern that we saw with the tray problem, where the empty places or spaces needed to be essentially counted, right? It takes a similar approach, because both of them, if you look at them, right, they start with the assumption that all the rows and the columns are sorted in ascending order, right? So that is one of the primary assumptions, right? So let's actually try and do that. And yeah, actually Monday, right, which is going to be day after tomorrow, that's going to be, it will have to extend that class a little bit, because we have one problem to solve, which is this, and we have another problem which is also on arrays, and it is actually on some kind of combinatorics problem, right? It is actually a little more advanced, where you actually look at permutations and combinatorics and all those things. Okay, so yeah, Monday is going to be a hectic day, surely, because you're going to be looking at different problems, and eventually we want to finish this on Tuesday, because it's a 5-series program, 5-part series. So we want to finish that on definitely on Tuesday. Okay. Yeah, we may have to stretch, but we'll do that. Okay. All right. So can we call it a day today, and then come back and then continue to work through this problem? Okay. Yeah. Surely. Why not? Yeah, because I want you to be fresh as well when you actually look at these things, and that'll also make a difference as well, right? Okay, all right, then we'll call it a day. Good night, folks, and then we'll catch up on Monday. Good night, and good rest of the weekend. Bye.